So the way we're going to break this down, you guys, okay? These steps right here. If you follow these steps every time, there's no reason to get any of these graphs or any of these details incorrect, okay? The most important thing, okay? First, you factor and you find the domain, okay? 2, where it says right in lowest terms, this essentially just means, after you factor, cancel if there's any common factors. Okay, that's the second step. Third, locate the intercepts. Okay, this is pretty easy. The Y-intercept's the easiest one. How do you find a Y-intercept? Yeah, let's just do it the old-fashioned way. Plug in 0 for x. Okay, so I'm just going to jump ahead real quick. Down here, you see if I plug 0 in right away, what happens? We get -1 over -4, so the y-intercept's a quarter, 1/4. Does that make sense? Okay. The x-intercepts are the zeros of the numerator. Okay? So, yeah, in this case, it'll be 1. If you take the numerator and find the zeros of the numerator, everybody remember how to do that? You just add and you get 1, right? Okay, so that's step 3. You find your intercepts. Step 4, locate the vertical asymptotes. And we talked about that yesterday. Those are the zeros of the denominator. Okay? I'm just reviewing all the things we're going to do, and we'll go ahead and do it. Once you have the vertical asymptote, then we have to make a decision. Is there a horizontal or is there an oblique asymptote? How do we know which one it is again? Yeah, we look at the degrees. If the denominator is greater, then it's 0. If the denominator is less, then there's an oblique. If the degrees are the same, then we do the leading coefficient divided by the leading coefficient. Those are the 3 scenarios. This is going to be a little bit tricky right here, this last part. Determine if the graph intersects the asymptote. This is what I was talking about yesterday. Vertical asymptotes, we never go past those or through those, but it is possible that we might intersect an oblique asymptote or a horizontal asymptote. And I'll show you how to do that when we get there. Okay? Once you've done those first 5 steps, you guys, and you have all these details filled out, you basically just graph the equation on your calculator and then use that to help you graph it. It's that easy. Okay, so let's just go ahead and do all those things for the first problem. Can I factor this at all?
Yes.
So what is the bottom factor to? Okay, so x minus 2, x plus 2. Can we reduce this at all? No, because there's nothing in common. Okay, so step 1 is done. Step 2 is done. Now we want to find the intercepts. So I'm just going to go down here and find the x-intercepts first. X-intercept, we take the numerator and find the zeros there. So we get 1. Okay, if at any point I go a little quick or you're not following, please just stop me. The y-intercept, we're going to plug 0 into x. You can do it either at the very beginning or after we factor, but you know what? It's easier here, because you can see your answer when you plug in 0, can't you? Here you'd actually have to do like 0 minus 1, 0 minus 2, 0 plus 2, and then figure that out. Here you see right away you get -1 over -4. So the y-intercept is -1/4. Everybody good so far? Positive. Negative over a negative is positive. Oh, and I forgot the final piece for 1, the domain. Remember, the denominator can never equal 0. So what can x not be? Plus or minus 2. So this is the domain. Okay. Since nothing reduces, like nothing cancels out, these values that we have, since those are the zeros of the denominators, are the same values we use for our vertical asymptotes. So we're going to have 2 and -2 as our vertical asymptotes. Well, the vertical asymptote is a line, so it's equal, yeah. finding the zeros for each one. Okay. Everybody good with the first three details?
Yes.
Now we have to make a decision. The degree is 1 for the numerator and 2 for the denominator. So what does that translate to? Very good. Y equals 0. Okay, so now here's what I'm going to ask you to do. Before you graph and start drawing the picture, okay, before you do, use the graphing calculator to figure this out, just label your graph with these details. So for example, the x-intercept is 1. So I'm just going to put a dot or a point there and label it 1. The y-intercept is a fourth. So I'm just going to put a point and label it 1/4. We have two asymptotes. X equals 2. If this is 1, then 2 is just a little bit to the right. I'm going to put my dotted or dashed line and label it x equals 2. Also, on the other side, at -2. Okay? And there's a horizontal asymptote at y equals 0. Now, I'm going to show you this even though it's going to be redundant, because do you guys see that we already have a point on this horizontal asymptote?
Yeah.
So it's definitely going to hit it, maybe even go through it. Okay? I'm going to show you what you would do just to check using algebra to see if it goes through or not. Okay? So to check if it crosses horizontal or oblique asymptote, you take this equation, whatever it is, y equals 0, or if it's something else, and you're going to go ahead and plug that in and set it equal to 0. So if you take this and make your function, which is x minus 1 over x minus 2, and then x plus 2, and set it equal to 0, watch what happens. First, I would multiply by the denominator, right? But I'm multiplying it with 0, so what happens? You just get 0. So now this becomes 0 equals x minus 1, and what do we learn here? That at x equals 1, there's a point on this 0 asymptote, which we already knew, but that's how you would check if you didn't have that on your graph already. Does that make sense? Okay. That's it, you guys. If you can do all this, now we're going to use our calculators. Okay. Go ahead and type in the equation there. X minus 1 divided by, since nothing reduced, I'm going to go ahead and just use the original because it's less typing.
Do we put it all in parentheses?
Yeah, the entire numerator and denominator should be in parentheses. The other option, which I'll show you guys in review, is this. If you press alpha y equals, you get this little option that you can create a numerator and a denominator, and then now you just type it in exactly the way you see it. Okay, so you could go, x minus 1, and then x squared minus 4. Okay, and look, it might be the case that we have to play around with the window a little bit, but what's the first window we should start with? The standard window. So if you go to zoom, very good. We go to zoom and press 6. I think that's good enough for our picture, right?
Yes.
Okay. You don't need to have any specific details besides the ones we've already found. So now your graph is going to look like this. On the left-hand side, do you guys see that we're underneath the horizontal asymptote? So we're just going to copy that. So there's that section. In the middle, you guys see how we're it almost looks kind of like a cubic, right? In the middle there. We're going to do that exact same thing. Keep in mind that as we get to these asymptotes, we should be getting closer. Same thing here, same thing down here. And on the right side, it looks like we're above the x-axis. So this is what I would expect from you guys. It's not as bad as you thought, right? I mean, there's a lot of little details and a lot of little steps you have to follow, but I think you guys can do this, okay? Any questions on that first example. All right, my goal is, yeah, go ahead.
What's the difference between the horizontal and oblique?
An oblique asymptote is usually like a line, like a slanted line with a slope. Horizontal is flat.
And then the vertical is up and up.
Exactly.
So by asymptote, that means it gets closer to the. So it is the vertical asymptote. It gets closer to.
So on each side of the vertical asymptote, the graph should be getting close to it. That's what's going on here. The horizontal asymptote represents end behavior, like all the way at positive infinity and all the way at negative infinity. It's very possible that in the middle of our graph we go through it or maybe touch it and then come back around.
But that's only for horizontal.
Yes.
So for the other ones, it can never actually go through.
Yes. Yes. Any other questions? Okay. Let's go to example 2. Okay. Can we factor the numerator? To what?
X minus 3.
What?
X minus 3?
He's
X
right.
minus 2.
Very good.
Yeah, what are you about, huh? Yeah.
What do you think about Erica's hair? Chill out.
Okay. Let's settle down.
Should you use 6 negative 1?
No.
It doesn't multiply to positive 6.
What?
Okay. Already reduced, right? We can't cancel anything out. I'm going to write down the domain just in case I need it later. What's the domain? X cannot equal negative 2. Okay. What cancels out? It has to be identical.
Oh, yeah, true.
It's got to be exactly the same. X minus 2 and X minus 2 would cancel. And that creates a whole different thing, but we'll get to that later.
All right.
Okay, X-intercepts. How do I find the X-intercepts? Where do I look again? The numerator. What are the zeros?
3 and 2.
Pretty easy, right? Once it's factored, this is not hard. The Y-intercept. Nothing canceled out, so you have your choice. You can use the original or this one. Which one would you plug 0 into? I would actually argue the top, because if you put 0 in there, 0 in there, and 0 in there, what's left? 6 divided by 2, so the Y-intercept is 3. Okay. Otherwise, I mean, you still get the same thing, but you'd have to actually figure it out. You know what I mean? Vertical asymptote comes from the denominator. The 0 of the denominator is x equals negative 2. Horizontal or oblique, we got to look at the degree. This is degree 2 in the numerator and then degree 1 in the denominator. So this translates to an oblique asymptote. So this is the first one we're going to graph with an oblique asymptote. How do we find it now?
Ooh, the thing we learned last.
Yeah, the thing we learned last unit.
The thing in the corner.
So we're going to divide this x plus 2. What does that mean I put in this little... So negative 2. Write down the coefficients. 1, negative 5, and 6. Bring down the 1. Multiply, you get negative 2. Add, you get negative 7. Multiply, you get 14. We get 20. What do we not care about here?
The remainder.
Good. What does this translate to? What equation is that?
X minus 7.
Very good. So there's my oblique asymptote. Let's try to put everything we've got on our graph and then check it out and copy it down. X-intercept is 3. And there's also one at 2. There's a Y-intercept at 3. A vertical asymptote at x equals negative 2. And now we have to graph this thing right here. How do we graph the line y equals x minus 7? So you go down to negative 7, There's an intercept right there, right? And then the slope is just up 1 over 1. So it's going to look something like this. And so what I'm going to do, even though I'm going to extend into the next problem, I'm going to extend my asymptotes so that I have plenty of room here. Okay? Everybody good so far? Well, don't guess. It's either a yes or a no. Okay? You guys see that if I start at -7 and I go up and over 1, that this is going to cross at 7? So we know for sure we're on the right of these intercepts. Okay? Okay. Let's graph it. I mean, look, honestly, let me show you something that might save you some time. You're not required at all to do this by hand, but sometimes you can look at it and you know what the answer is going to be. Okay? For example, do you kind of see what's going on over here in this section?
Yeah, it's going to be one of those.
Do you mean one of these?
Yeah.
Okay. Kind of like a parabola that goes through all 3 of these points, right?
Yeah.
Does that make sense? So that's my guess, anyway. Over on this side, we have to make a decision. Is my graph going to be up here following these asymptotes, or is it going to be down here in this little section?
Down.
Why here?
Because the rest of the line, the -7 line, is like that way.
Okay, there's another reason too. You know how over here I had these points, and I was like, oh, it's easy to fill in, right?
Yeah.
What would I have to do if I had this as my answer? What would I have to see? What did I just do right here?
You made another X.
I would have to have another x-intercept on this side.
Yeah.
We don't have an x-intercept over there. Does that make sense?
Yes.
So by process of elimination, I'm so confident without a calculator, I'm going to go ahead and just, this is my graph. Okay? That's what I'm, just based off of the information I found, that's what it has to look like, you guys, just by eliminating the obvious here. And if you're not good at that or you're not really 100% sure, you'll have your calculator available. I don't know if anyone's already typed it in, but it does look like this, right? It doesn't have the bottom one? Ah, well, let's see what's going on there.
I think we all need to buy you a pencil. You say that every time. I don't need that. Put the eraser.
Let's see.
I think you need that pen that you can erase it.
So it does look like that.
Yeah.
Are you wearing 2 J's?
And so now here's what we got to do. Now if we zoom out,
Oh, got him.
Oh, there it is.
you can confirm that the other part of the graph is down there on the left. Okay? All right. All right. That's a good place to stop for today. We're going to continue with this tomorrow, okay?